Hi everyone, Mrs. Jones here. First of all, I want to congratulate you that you are officially at the end of your remote learning for algebra. This is your very last remote learning video for spring of 2020, so congratulations. You guys have worked really hard over the last 10 weeks, and this video is your last one, so awesome job. In this video, I'm going to show you how we can use our graphing, substitution, and elimination to be able to solve system scenarios. So we're going to put some of these strategies to work, but with system scenarios, so real life situations where we can understand what's going on. Let's get started. All right, this one's for all you Justin Bieber fans out there. I know you're there somewhere. It says Elizabeth is going to a Justin Bieber concert. Awesome. She knows that 2,200 people are going to be there, including herself. Kid tickets cost $3 and adult tickets cost $5. Holy moly, amazing. And she knows that they raised $9,600 in total. How many kids are going to the Justin Bieber concert? So our goal here is that we want to write a system. When we write that system, we need to have two variables, but we don't know what those variables are right now. So we need to define them. We need to, in other words, tell me what does X represent and what does Y represent. One of the ways to look out for how you know what that is to look at your question. The question asks how many kids are going to the concert. So I'm going to say that X is going to represent the number of kids. The other piece of information that we don't know is the number of adults. So we have two variables, but now we need two equations. So we need to look at the two different pieces of information. The first of which is that there's 2,200 people in attendance. So I know that the total number of kids plus the total number of adults is going to be 2,200. The other piece of information we know is about the cost. I know that every child paid $3 and every adult paid $5, which got us a total of $9,600. That is my system. So now I need to solve it. Hopefully you remember from Mrs. Bix's video from yesterday that this is a great system to use elimination on. So what I'm going to do is I'm going to multiply my top equation by -3. When I do this, I end up with -3x minus 3y equals -6,600. I'm going to copy down my bottom equation, which is 3x plus 5y equals 9,600. And now I'm going to add my equations together in order to cancel out my x's. So I'm going to be left with 2y equals 3,000. When I divide both sides by 2, I know y equals 1,500. But y wasn't what we were looking for. We're looking up here for the number of kids, so I now need to solve for x. So I'm going to use my top equation, and I know that x plus, instead of y, I'm going to plug in the 1,500 that we just solved for, equals 2,200. I'm going to subtract 1,500 on both sides, and I'm going to get a solution of x equals 700. Now, if we were to graph this, right, my intersection point, meaning my solution, would be 700, comma, 1,500. If we think about it in terms of our scenario and interpreting it, I know that the 700 represents the number of kids, and that's what the question was looking for, so that's our answer. But we also know the 1,500 represents the number of adults. All right, hopefully that made sense. Let's try another one. Okay, it says Teddy is selling lollipops for $1 each and cookies, for $2 each. He sells 50 items and makes $80. How many lollipops does Teddy sell? How many cookies does he sell? All right, I want you to pause the video here, and I want you to try to write the variables. What do they represent? And then I want you to try to write the system. All right, you're back. Hopefully you got this information. Hopefully you said that the variables were going to represent the number of lollipops and cookies. Notice here that I actually decided to use L and C. You can use X and Y. You can use any variables that you want. Of course, if we're graphing, you want to use X and Y. But we're not graphing here, and I'm going to actually use elimination. So I decided to use L, and I used a cursive L so that it doesn't look too much like the number 1, and a C for cookies, because I just think it helps me make more sense of it at the end. Hopefully you got this system of L plus C equals 50 and L plus 2C equals 80, because we know there's a total of 50 lollipops and cookies. $1 per lollipop, $2 per cookie, gets us $80 in total. All right, I want you to pause now and try to solve it using their substitution or elimination. And you're back. So I used elimination. I started by multiplying the top equation by -1. I then added my equations together and got C equals 30. And then I plugged C equals 30 back into the top equation and solved L for 20. So I know that Teddy had 20 lollipops and 30 cookies that he sold. All right, let's try one more. Sam mowed his neighbor's lawn for a handful of dimes and nickels. He counted 80 coins in total. Upon completing the job, he counted out the coins and it came to $6.60. How many of each coin did he have? All right, I want you to pause the video here, try to write the variables and the system. And you're back. So again, I used D and N here to represent dimes and nickels. I said D plus N equals 80 because we have total 80 coins. And I said 10 cents per dime plus 5 cents per nickel equals $6.60. The one thing that I want to draw your attention to here are these decimals. And if we look really carefully, we can see that the worth of our dimes here, I'm writing this in terms of dollars, right? The way that I've written 5 cents and 10 cents is in terms of dollars. I could make this easier on myself if I wanted to, and I could write this as 10D plus 5N equals 660. What I've done here is I've actually changed it so that all of my units are in cents because I've gotten rid of the decimals. Notice that the black equation has dollars, right? I've written that 10 cents in terms of dollars, but the blue equation shows everything in terms of cents. Notice the $6.60 became 660 cents. I am then going to use this equation and I'm actually going to multiply it here by I'm going to multiply the top equation, by -10, and then solve the system using elimination. So I actually used this equation and this equation, not this one, because I would rather not work with the decimals. Then, once I multiplied that top equation by -10, I rewrote my blue equation down below, 660, and then I added the two equations to get rid of the 10, and I got -5n equals -140, which solved, I divided by -5 on both sides and got n equals 28. I substituted that 28, I plugged it into the top equation and solved d equals 52. So this means that Sam, after mowing the lawn, earned 28 nickels and 52 dimes. So I hope this makes sense. Again, congratulations on finishing your last video. If you have any questions, let us know. There is a worksheet for you to complete. And believe it or not, you're almost done with 8th grade algebra. Congratulations. Good work.